Hello students, welcome to the class. Already we have discussed the synopsis of kinetic theory of gases. Let us continue with the questions. The first question is, the root mean square speed of hydrogen molecule of an ideal hydrogen gas kept in a gas chamber at 0 degrees Celsius is 3180 meter per second. So the root mean square value of hydrogen gas is given. It is kept in a chamber, gas chamber at 0 degrees Celsius. The pressure on the hydrogen gas is, we need to calculate the pressure on the hydrogen gas. What all they have given, the temperature is given, pressure value, 1 atmospheric value is given, then its root mean square velocity and the density of hydrogen is given. So we know that the relation between pressure, density and root mean square is given by that is P is equal to 1 divided by 3 rho into V RMS square. So this is equal to this 1 divided by 3 into density, how much it is given? It is 8.99 into 10 raised to minus 2. V value, it is 3180 meter per second. Its whole square, it is V square. Okay. So here if we simplify this, we will get it as 3.03 into 10 to the power of 5 Newton per meter square. 3.03 into 10 to the power of 5 Newton per meter square. So this can also be written as 3.3 atmosphere. 3.3 atmosphere. Why? Because here you can see 1 atmosphere is equal to, it is 1.01 into 10 raised to 5 Newton per meter square. Therefore, here whatever 10 to the power of 5 Newton per meter square is there, we can write it as atmosphere, 1 atmosphere. Therefore, the options are 0.1, 1.5, 2 and 3.0. So here option D is the right option. That is 3.03 atmosphere is the answer. Option D. Next question. The temperature of a gas is raised while its volume remains constant. Okay, the temperature of the gas is increased, but the volume remains constant. The pressure exerted by a gas on the walls of the container increases because its molecules. So here the three factors they have given. One is the temperature is increasing, volume is remaining constant, and pressure also increasing on the gas. Here what happens now? Due to increase in temperature, the root mean square velocity increases. See here, we know that. See what all options they have given. Lose more kinetic energy to the wall. They are in contact with the wall for a shorter time. Strike the wall more often with higher velocity. Then fourth option is collide with each other with less frequency. See here, when the temperature value increases, the temperature value when it is increasing, the root mean square velocity, that is RMS, VRMS of the molecule also increases. So when temperature increases, root mean square value also increases. Therefore, the molecules strike the wall more often with higher velocity. Therefore, the molecules will strike to the wall with more velocity. Hence, the pressure exerted by the gas on the wall of the container increases. So, when these are moving with more speed, at that time what happens? It will create the pressure on the wall of the container. So, option C is the right option here. Strike the wall more often with higher speed. As the temperature increases, root mean square velocity of the molecule increases. So when root mean square increases, it starts moving more rapidly. It will hit the wall. So when it will hit the wall, the pressure on the wall increases. Therefore, option C is the right option here. Next question. A flask contains 10 to the power of minus 3 meter cube gas. So volume is given. At a temperature, the number of molecules of oxygen are 3 into 10 to the power of 22. So they have given the number of molecules of oxygen. The mass of an oxygen molecule is, mass of oxygen molecule is given 5.3 into 10 to the power of minus 26 kg. And at that temperature, the RMS velocity of molecules is 400 meter per second. They have given the number of molecules, volume, then mass and RMS velocity. We need to calculate the pressure here. So in the first question, we have seen the expression for pressure. That expression was in terms of density. Now we need to take it in terms of mass and volume. Here the expression is what? P is equal to 1 divided by 3. It is rho into V square, VRMS square. So here instead of density, we are taking mass, that is mass per unit volume. As n number of molecules are there, we will write it as m into n into VRMS square. This is equal to, see this 1 by 3 I'll write as it is. Mass is given as 5.3 into 10 raised to minus 26 into number of molecules, it is 3 into 10 raised to 22 divided by, so divided by it is V. So V value is 10 raised to minus 3. And here it is V RMS square, its value is 400. Right? So it is given 400 meter per second. Therefore, it is 400 whole square. If you simplify this, we will get pressure is equal to, pressure P is equal to, it is 8.48 into 10 to the power of 4. 8.48 into 10 to the power of 4. So here we can see option A is the right option. Option A is the right option, right? So pressure, mass and volume relation. Next question. A gas at a certain volume and temperature has pressure 75 centimeter. So volume and pressure, both are at a 75. So the pressure is 75 centimeter. If the mass of the gas is doubled at the same volume and temperature, what happens to the pressure? So if mass increases, what happens to the pressure value? Here the equation is, or the formula is same, that is 1 by 3 m divided by V into V RMS square. What they are saying, if the mass is doubled, if the mass value is doubled, what happens to the pressure? So here by the equation, we can see that mass is directly proportional, sorry, pressure is directly proportional to mass. When pressure is 75, the mass is m. When the mass becomes 2m, the pressure also becomes 2 times, that is 150. That is, it also becomes twice of that value. So it is 150. Option C is the right option. Next question. A gas at 27 degrees Celsius has a volume V and pressure P. On heating, its pressure is doubled and volume becomes 3 times. So a gas at 27 degrees Celsius, it has a volume of V and pressure is P. On heating, its pressure is doubled. So when you heat it, its pressure is doubled. Then volume becomes 3 times. The resulting temperature of the gas will be. So how to do this? From ideal gas equation, we have the equation as PV is equal to mu RT. PV is equal to mu RT. Therefore, it is T2 divided by T1 is equal to P2 divided by P1 into V2 divided by V1, which is equal to what they are saying, the pressure is increased to 2 times. So it is 2P1 divided by P1, and the volume value is increased 3 times. Therefore, it becomes 3V1 divided by V1. So this is nothing but this is equal to 6. So what we got here, we got it as T2 divided by T1 is equal to, we are getting it as 6. Therefore, T2 is equal to 6 into T1, which is equal to, so 6 into T1 is given as 27 degrees Celsius. We want it in terms of Kelvin. So in terms of Kelvin, it is written as 273 plus 27. That is nothing but 300. So 6 into 300. 6 into 300 is nothing but it is 1800 Kelvin. It is 1800 Kelvin. The options are given in terms of degree Celsius. What we can do? We can subtract again 273 from this. So we will get it as 1527 degree Celsius. 1527 degree Celsius. That is option C is the right option. Option C is the correct option. 1527. According to ideal gas equation, PV is equal to mu RT is the given equation. Then next, substitute the values. Take the ratio, substitute the values, then simplify this. We will get the answer 1527. That is option C is the right option. Next question. Air is filled at 60 degrees Celsius in a vessel of open mouth. The vessel is heated to a temperature T, so that 1/4 part of air escapes. Assuming the volume of vessel remaining constant, the value of T is. So the question is what? Air is filled at 60 degrees Celsius in a vessel of open mouth. Okay. In a container or in a vessel, the air is filled at 60 degrees Celsius. When the vessel is heated to a temperature T, the 1/4 part of the air escapes out. Means when you start heating it, 1/4 part of the air escape out. Assuming the volume of vessel remaining constant, the value of T is. So we need to calculate the value of T. At what temperature this gas will escape out. Let us see. That is given by so I'll consider M1 is equal to M and T1 is equal to, in terms of Kelvin, I'll take it is 60 plus 273, that is 333 Kelvin. Next, M2 is equal to, so M2 is equal to, I can write it as, it is M minus M divided by 4. Why? Because when it starts heating, the mass reduces to 1/4 of its value. Therefore, it becomes M minus M divided by 4. So this is M minus M divided by 4. This is nothing but 3M divided by 4. It is 3M divided by 4. From ideal gas equation, it is given by PV is equal to mu RT. It is given by PV is equal to mu RT. So by using this equation, we can solve it as previous one numerical formula, that is T1 by T2 is equal to, here we will take it as M1 divided by M2, which is equal to, so this M1 mass is M, M2 mass we have calculated it as 3M divided by 4. So if I simplify this one, it becomes 4 divided by 3. That is T2 is by T1 is equal to 4 by 3. Therefore, T2 is equal to 4 by 3 into T1. That is equal to 4 by 3 into T1 value is how much? T1 value is, it is 333. So therefore, 3 ones are 3111. That is nothing but 444 Kelvin. 444 Kelvin. In terms of degree Celsius, we want. So in terms of degree Celsius, it is 171 degree Celsius. It is 171 degree Celsius. That is option D is the correct option here. Okay. Next question. The conversion of ideal gas into solid is dash. It is possible only at low pressure, possible at low temperature, possible only at low volume. It is impossible. See here, the conversion of ideal gas into solid. It is not at all possible. It is impossible. Why? Because there is no force of attraction between the ideal gas gas molecules. Therefore, we cannot convert gas into solid. That is ideal gas into solid. Okay. Option D is the correct option here. Next question. At room temperature, the RMS speed of the molecule of certain diatomic gas is found to be. So, at room temperature, RMS value is given. Which gas it is? See, we know that whether it is H2, O2, Cl2 or F2. Let us see. The root mean square velocity is given by, it is equal to 3RT divided by M. This value they have given it as how much? 1930. Here simplify this equation for M is equal to. So squaring the equation on both the side and simplifying it for M, it becomes M is equal to 3RT divided by VRMS whole square. So this is equal to, substitute the value 3 into R is 8.31 into temperature is 300 because it is given as room temperature. So if we consider 27 degrees Celsius in terms of Kelvin, it becomes 300 Kelvin divided by VRMS value. It is given as 1930 V square it is, therefore its whole square is equal to. So here we can simplify this equation. Substitute, simplify, you will get it as 2 into 10 raised to minus 3 kg. 2 into 10 raised to minus 3 kg. So this 2 into 10 raised to minus 3 kg is nothing but it is 2 gram. It is 2 gram. So when we are getting mass as 2 gram, which means that it is hydrogen molecule. It is hydrogen molecule H2. Option A is the right option here. So based on the mass, we can calculate. Suppose if you get here 16, it will be oxygen. Right? If you get it as 35, then it will be chlorine. So based on the mass, we can understand which molecule it is. Next question. The root mean square speed of hydrogen molecule at 300 Kelvin is 1930 meter per second. Then the root mean square speed of oxygen molecule at 900 Kelvin will be. So here we need to take the ratio of the molecules. That is, so formula is, we know already the formula. Vrms is equal to, it is under root of 3RT divided by M. 3RT divided by M. Here, the ratio of hydrogen to oxygen is equal to under root of 3RT divided by M it is. Therefore, we can simplify it as it becomes T of H2 divided by M of H2 into mass of O2 divided by temperature of O2. It is equal to. So, for hydrogen, the value is 1930 divided by, for oxygen, it is written as it is because for oxygen we need to calculate. Temperature of hydrogen is given. Mass of hydrogen we know that is 2 into. Then mass of oxygen is 32 and temperature is given, it is 900. Simplify this. So if we simplify here, we will get it as, it is 2, this is 2. It is 1 by 3 into 16 by 1. That is nothing but 16 divided by 3. We will get it as 16 divided by 3, which implies for oxygen, this becomes 1930 into root of 3 divided by 4. So what I did here, 16, square root of 16 is 4. So 1 divided by root 3 is there. If it goes to the other side, it becomes into root 3 divided by 4. So now you can simplify here. So if I simplify this, we will get it as 836 meter per second. 836 meter per second. That is option B is the right option. Next question. An ideal gas, the adiabatic constant value is given as 1.5, is expanded adiabatically. How many times has the gas to be expanded to reduce the root mean square velocity of molecules? 2 times. So gamma value is given. They have asked you how many times you need to reduce the root mean square velocity of molecules, which has to be expanded twice. That is, so to reduce, we need to reduce it. Therefore, to reduce the root mean square 2 times, the temperature should be reduced 4 times here. That is T2 is equal to T1 divided by 4. T2 is equal to T1 divided by 4 here. Adiabatic relation, we know it is given by TV raised to gamma minus 1 is equal to what? It is constant. Right? It is written as V2 divided by V1 to the power of gamma minus 1 is equal to T1 divided by T2, which is equal to how much? It is equal to 4. It is equal to 4. Gamma value is how much? It is given, it is 1.5. So we can substitute the value here. We can simplify this equation as V2 divided by V1 is equal to 4 to the power of. Here to the power of gamma minus 1 is there. So if I take it on the other side, it becomes 1 divided by gamma minus 1. Which implies V2 is equal to V1 into 4 into to the power of 1 minus gamma minus 1, that is 3 by 2 minus 1. So is equal to V1 4 to the power of 2. That is nothing but V4 square is 16. It becomes 16 into V1. It becomes 16 into V1. Which means that the V2 must be 16 times of V1 so that the root mean square velocity should be reduced to 16 times so that the gas will expand twice of its value. Okay. Then At which of the following temperature would the molecules of a gas have twice the average kinetic energy they have at 20 degrees Celsius? We need to calculate the temperature of the molecule so that it should have twice the kinetic energy of the molecule when it is at 20 degrees Celsius. See here, it is given by E2 divided by E1 is equal to T2 divided by T1. So what they said, the energy should be twice, therefore it is written as 2E1 divided by E1, which is equal to T2 divided by T1 is 20 plus 273. So even will get cancelled. Here you will get it as T2 is equal to, it is written as 293 into 2. 293 into 2. So 293 into 2, it is how much it is? 586 Kelvin. It is 586 Kelvin. So our options are given in terms of degree Celsius. Therefore, in terms of degree Celsius, minus 273. That is nothing but 313 degree Celsius. Means at 313 degrees Celsius, the kinetic energy of the molecule becomes twice whatever the value it had at 20 degrees Celsius. So option C is the correct option. Next question. The average translational energy and the RMS speed of molecules in a sample of oxygen gas at 300 Kelvin are. So at the temperature of 300 Kelvin for oxygen, the average translational energy is given as 6.21 into 10 raised to minus 21 joules. The RMS speed is 484 meter per second. The corresponding value at 600 Kelvin are nearly. We need to calculate at 600 Kelvin what is the value of RMS velocity and the translational energy of the molecule. So we can take the ratio of the equations here, that is see, we know that energy is equal to, it is 3 by 2 into kT. Okay. So Vrms can be written as, it is Vrms is equal to, it is under root of 3RT divided by M. 3RT divided by M. So by this equation, we can see that E is directly proportional to temperature. And by this equation, Vrms equation, we can see that Vrms is directly proportional to square root of temperature. So when the energy becomes twice, that is when the temperature becomes twice, because see, initially the temperature is given as 300 Kelvin. The next, the temperature when it becomes 600, which means it is double of that value. So when energy becomes twice, what happens to its temperature? We can write it as, it also doubles here, that is energy is equal to 2 into, energy is how much? It is 6.21 into 10 raised to minus 21. So that is 12.42 into 10 raised to minus 21 is what? This is energy. So if you see the option, already option D is having the same energy, that is 12.48 into 10 raised to minus 21. Other options are different. So directly we can go for this option. Or if we want to verify with the RMS value also, we can verify it. So here it is given that 484. So 484 is there. Then Vrms and temperature, what is the relation? It is square root of that value, right? So here with the same process we can do and we can calculate Vrms also. We will get it as 684 meter per second. Therefore option D is the correct option. Let's see the next question. The adjoint figure shows, so here you can see the figure of the graph of pressure versus volume of a gas at two temperatures T1 and T2. Which of the following inferences is correct? See the graph, that is the pressure value is decreasing as the volume is increasing, right? But at constant temperature, sorry, constant pressure, the value of volume and temperature are proportional to each other, correct? That is according to Charles' law, we can say that V is directly proportional to T. So from the graph, it is clear that you can see in the graph here, this part, second one, T2. You can see the T2 is greater than the T1 value at the same pressure. So when the pressure is kept constant, the volume is directly proportional to temperature. But in this graph, you can see that at that particular pressure, the temperature of T2 is greater than T1. That is option C is the correct option here. T2 is greater than T1. Option C is the right option. Okay. Next question. A perfect gas at 27 degrees Celsius is heated at constant pressure to 327 degrees Celsius. So temperature is 27 degrees Celsius. Pressure is given as 327 degrees Celsius. If original volume of gas at 27 degrees Celsius is V, then volume at 327 degrees Celsius is. See here, it is V2 divided by V1 is equal to T2 divided by T1. This is equal to. So T2 is, it is 327 plus 273 divided by, here it is 27 plus 273. Therefore, this is V2 is equal to 600 divided by 300 into V1. So these two zeros will get cancelled. 3 ones are 3 twos are. That is nothing but 2 into V. 2 into V. 2V. Option B is the right option here. Okay. Option B is the right option. 2V is the answer. Next question. Pressure versus temperature graph of an ideal gas of equal number of moles of different volumes are floated as shown in the figure. Pressure versus temperature graph is given for an ideal gas. Here the number of moles of different volumes are floated as shown in figure. Choose the correct option. See, options are given as V1 is equal to V2 and V3 is equal to V4 and V2 is greater than V3. Option 2. It is V1 is equal to V2, but here V2 is less than V3. Option 3, all are equal. Option 4, V4 is greater than V3, which is greater than V2, which is greater than V1. See here, we have equation of a straight line that is given by y is equal to mx plus c. If you see the graph here, if you observe the graph, the slope of line 1 and 2 is less than, the slope of 1 and 2 is less than slope of 3 and 4, correct? So we can observe in the figure. That is, we have, that is P is equal to, we have P is equal to mu RT divided by V. But we know that V is inversely proportional to what? Slope here. And in the figure, we can observe that the slope of 1 and 2 is less than slope of 3 and 4. So the points 1 and 2 are on the same line. They will represent the same volume. V1 is equal to V2. Okay, so that is V1 is equal to V2. Point 3 and 4 are on the same line. Therefore, they will represent the same volume. V3 is equal to V4. So you can see option 1 and 2. But which is right? V2 is greater than V3 or V2 is less than V3, which is right here. Here, the volume of 1 and 2 is greater than the volume of 3 and 4. Why? Because slope and volume are inversely proportional. So we know that the slope of 1 and 2 is less than 3 and 4. So when the slope value of 1 and 2 is less, the volume of 1 and 2 will be more. Therefore, we can say that V2 is greater than V1. Sorry, V3. That is option A is the correct option here. Option A is the right option. Okay. The average kinetic energy per molecule of helium gas at temperature T and energy E and the molar gas constant R, then Avogadro's number is. So the kinetic energy per molecule of helium gas at temperature T is E. Okay. Then the molar gas constant is given as R. So the Avogadro's number we need to calculate here. So it is given by, that is E is equal to 3 by 2 K into T. So here K is equal to, it becomes 2 by 3 E into, sorry, E divided by T, which is equal to, we know that the Boltzmann constant and the gas constant and Avogadro's number relation, that is K is equal to R divided by N into A. So in this equation, we can take K is equal to R by A here, R by NA, which is equal to 2 by 3 into E by T. We want Avogadro's number NA is equal to, therefore NA is equal to, it becomes R divided by 2 by 3 into E by T. Right? So if I simplify this one, it becomes 3RT divided by 2 into E. 3RT divided by 2 into E. That is option D is the correct option here. Option D is the correct option. Next question. CO2 is a triatomic gas. Mean kinetic energy of 1 gram gas will be, see here, if N is the Avogadro's number, K is Boltzmann constant, then molecular weight of CO2 is equal to 44. We need to calculate the kinetic energy of the molecule. That is so energy is equal to, it is mu into 7 by 2 into RT. That is equal to, so here mu can be written as M divided by capital M into 7 by 2 R into T which is equal to, it is 1 divided by 44, 7 by 2 into RT can be written as N into K into T. So which is equal to, U is equal to 7 divided by 88 N K T. 7 divided by 88 N K into T. That is option D is the right option. Okay. The energy is equal to expression we need to take. So for triatomic molecule, the degree of freedom is 7. Okay, it is a linear one. Therefore, F value will be 7 here. Therefore, it becomes mu 7 by 2 into RT. Just substitute the value, then simplify. Next question. At standard temperature, and pressure, the density of a gas is 1.3 gram per meter cube, and the speed of the sound in gas is 330 meter per second. Then the degree of freedom of the gas will be. So we need to calculate the degree of freedom of the gas. They have given the gamma value and the speed value here, right? Therefore, it is written as V of sound is equal to under root of gamma into P divided by rho. Right. So we need the value of gamma. Therefore, gamma is equal to, it becomes V square rho in divided by P. So V value is 330 whole square, and the gamma value is, it is 1.3 divided by P. Pressure is, it is at 1 atmospheric pressure. Therefore, the value is 1.01 into 10 to the power of 5 is equal to gamma, right? Is equal to gamma. So simplify this one, the gamma value will be 1.41. The gamma value will be 1.41 here. This is equal to what? This is equal to your gamma value. What we need to calculate? The degree of freedom. Therefore, the degree of freedom and the gamma relation is given by gamma is equal to, it is 1 plus 2 divided by F. Therefore, F is equal to, how we can simplify? We can take this gamma this side, it becomes gamma minus 1 is equal to 2 by F. So therefore, it becomes 2 by F. Therefore, F is equal to what we can write? We can write it as 2 divided by gamma minus 1. That is 2 divided by gamma value is. Gamma value is how much? Just now we calculated. It is 1.4 minus 1. What is 2 divided by 0.4? 2 divided by 0.4 is 5. 2 divided by 0.4 is 5. That is option C is the right option. Okay, next. A gas mixture consists of 2 moles of oxygen and 4 moles of argon at temperature T. Okay. Neglecting all vibrational modes, the total internal energy of the system is. We need to calculate the total internal energy of the system. We have a mixture of gas, that is 2 moles of oxygen and 4 mole of argon is given. The total energy is given by, that is total energy is equal to U of oxygen, that is the energy of oxygen, plus U of argon is equal to, the equation is what? It is mu1 F1 by 2 into RT for oxygen. Then for this also it is same, mu2 F2 by 2 into RT. This is equal to, mu1 value is how much? It consists of 2 molecules. Therefore, it is 2 into, for oxygen, F1 value is 5 divided by 2 RT plus. Here the mu1 value, mu2 value is given as 4 and F2 value is given as 3 divided by 2 into RT. This is equal to. So here 5, 2 will get cancelled. 2 2s are 2 1s are 3 2s are 6. 6 by 5, that is nothing but 11 into RT. That is nothing but 11 into RT. That is option D is the right option. Option D is the right option here. Okay, then next. If the mean free path of atoms is doubled, then the pressure of the gas will become. So what is the relation between mean free path and pressure? We have an equation that is given by lambda is equal to 1 divided by root 2 into kT divided by pi d square into P. So here we can see that the pressure and the lambda value are inversely proportional. They are inversely proportional. So what they are saying here, the mean free path value is doubled. So when the value of this is doubled, it becomes half. It becomes half. That is option B. P by 2. Option B is the right option here. P by 2 is the correct option. Okay. Next question. A constant volume, the specific heat is given by 3R by 2, then the value of gamma will be. So the value of gamma will be. See here. So specific heat constant at constant volume is given by Cv is equal to R divided by gamma minus 1, which is equal to, this is 3R divided by 2. So here we can write it as gamma minus 1 is equal to R will get cancelled. Therefore, we will get it as 3 by 2. Therefore, gamma is equal to, it becomes 5 divided by 3. So this is the relation between specific heat constant and the gamma value. We can take this value and we can calculate the value of gamma here. Right option C is the right option, that is 5 by 3. Next question. The average degrees of freedom per molecule for a gas is 6. The gas performs 225 joule of work when it expands at constant pressure. The heat absorbed by gas is, so we need to calculate the heat absorbed by the gas. Okay, so here they have given that degree of freedom per molecule is 6, means the degree of freedom F value is given. To calculate the heat energy, we require gamma value. So first let us calculate the gamma value. Already we know the relation between gamma and degree of freedom, that is gamma is equal to 1 plus 2 divided by F, that is equal to 1 plus 2 divided by 6, that is nothing but 2 1s are 2 3s are, that is 1 by 3. So 1 plus 1 by 3 is nothing but it is 4 divided by 3 is the value of what? Your gamma value. Next. So we need to take, that is to calculate the heat absorbed, the work done divided by heat absorbed is equal to, work done is given by delta Q minus delta U divided by delta Q. Right. So this is equal to the Cp minus Cv divided by Cp, that is nothing but 1 minus Cv by Cp. Okay, so what is 1 minus Cp by Cv? That is called as what? 1 minus 1 divided by gamma. So here we have delta W by delta Q is equal to 1 minus 1 divided by gamma. That is nothing but delta W is 25 divided by delta Q is equal to 1 minus 1 divided by gamma value just now we calculated, it is 4 by 3. So transfer this delta Q, transfer all other terms. It becomes 25 minus 1, that is 24. 24 so you can simplify this, it becomes 3 by 4. 3 by 4 I can take first, then 1, just simplify it. Then if you simplify, you will get delta Q is equal to 100. You will get delta Q is equal to 100. Therefore, the correct option is option B. Option B is the correct option. 100 is the right answer. Next question. Real gases show markable deviation from that ideal gas behavior at. So the difference between real gas and the ideal gas. What is the main difference? See here, option is high temperature and low pressure, low temperature and high pressure, high temperature and high pressure. Then option D is low temperature and low pressure. See, in case the markable difference is that is low temperature and high pressure. That is option B is the right option here. Then the next question is moon has no atmosphere because of. So why moon doesn't have any atmosphere? It is far from away from the earth. Its surface temperature is 10 degrees Celsius. Both are not correct. Option C is what? The RMS velocity of all the gas molecule is more than the escape velocity of the moon surface, or the escape velocity of moon surface is more than the RMS velocity of the all molecules. See here, the option C is the right option. That is the RMS velocity of all the gas molecules is more than the escape velocity of the moon's surface. Remember this. Option C is the right option. Next question. Energy supplied to convert unit mass of substance from solid to liquid state at its melting point is called as. So what is it called as? You are converting from solid to liquid. So when you are converting from solid to liquid, what is the energy supplied? The energy supplied is called as what? Latent heat of fusion. Latent heat of fusion. So evaporation is what? From that is gaseous to vapor state, solidification, then latent heat of fusion. So it is correct option is option A, latent heat of fusion. Next, which of the following is the unit of specific heat? So which is the correct option here? The unit of specific heat is joules per kg per degree Celsius. Joules per kg per degree Celsius. That is option C is the right option here. Next question. An ideal gas is that which can be. So here, this is option B, that is joules per kg degree Celsius. Next, an ideal gas is that which can be solidified, liquefied, not be liquefied, not be solidified. That is not be liquefied. Option C is the right option. Next, average kinetic energy of molecules is, so always the average kinetic energy. Option are directly proportional to square root of temperature, directly proportional to absolute temperature, independent of absolute temperature, inversely proportional to absolute temperature. So according to the theory of assumptions of kinetic theory, we know that it is directly proportional to absolute temperature. Option B is the right option. Then the last question is, according to kinetic theory of gases, at absolute zero temperature, what happens? Water freezes, liquid helium freezes, molecular motion stops, liquid hydrogen freezes. See here, at absolute zero temperature, the molecular motion stops. Option C is the right option here. Option C is the right option. Okay. So next class we will see few more questions based on kinetic theory of gases. Thank you.